Am I audible, sir?
Yes, yes, sir.
So it's my pleasure to be here in front of 400 people to teach about or to have some chat about our studio. And I really thank SR University for giving me this opportunity to be a part of this good event. Um, so what I'm planning to do is I'm believing that all the participants for all here are very journals to R. So it starts from the very beginning, how R evolved and how we are going to use this R and what is RStudio, those things. I think I'll share my presentation now. If it is not visible, try to inform me. Is it visible? Is my screen visible?
Yes, sir. Yes, sir.
Okay. Okay. So our given topic is basic statistical analysis using RStudio. What I have planned today is I'll just try to brief how RStudio works and just a minute. Okay. Okay. So I have splitted this entire morning session into two sessions, which is session one for giving introduction to RStudio and data entry and data types. And the second one is how we visualize the data in R. Okay. My objective, what I have planned is in our 3 hours of class, predominantly I'll teach about how to use R and how to import data set, what are the types of data, how to manipulate data, those things for 2 hours. And data visualization is the last 1 hour. This is how I have split it, because if you know the basics well, visualization part is not that much tough. Okay. I have split it into 3 major topics. One is how to start with R and how it evolved. That is one kind. The second is how the data structures are and how do you convert a data structure into some other format, and how do you modify a data structure. This is my second part. Third one is how to manipulate the data set. So this is the 3 subtopics I'm going to explain. Begin with, so on 1970s, late 1970s, there people are very fragile in using C, C++. That is a very high-end programming languages where we need to code a lot to do the mathematical operations. But for the biologists like us, coding C, C++ and doing some data analysis is a very tough part. So the statisticians, 2 people from Auckland University, they have developed this R software, which is a precursor from S software. Okay. So they released their first copy in 2000. From then, R becomes R had a boom in data analytics, specifically in biological sciences. Why? Because this is an open source software, so anyone can download and use. And this is very simple, basic coding procedure. So even a person who starts learning R today, he can learn the basics in 1 or 2 days. That's very fine. So the convenience and the large amount of data it uses, very versatile with multiple libraries. So, and it is very interactive with other programming languages like Python, SQL. So this helps that R became the best statistical software for biologists. We heard about 2 things. One is R and RStudio. So what is R? R is a language like C, C++. RStudio is an ideally, which is we say like we are using some, like WhatsApp is a front end. The back end some codes will run. Likewise, in RStudio is an environment where you use the R software to run your codes. So that is how RStudio works. So RStudio is RStudio inbuilt don't have R, but we have to install R. In the face of it, RStudio will run. So whenever whatever the codes you run or write, it will compute that in R, then it will show it in RStudio. That is how it works. If you are the, I have given the links to download this R and RStudio. You can see in my link. This is CRAN. CRAN is a platform where most of the RStudio codes and RStudio root files, everything is available. If you go to POSIT website, that website is the owner for this particular RStudio. And there also you can get both R and RStudio exe files. So you can install them and you can use it. How RStudio looks like. So I'll show you my RStudio. This is my RStudio setup. Okay. So in general, if you see, there are 4 parts. One is called, if you are a new person, if you open it, it may looks like this, where there will be 4 panels will be there. The left top panel is source panel. The right top panel is called environment panel. Bottom left is called console. The right one is called output. Okay. So what is the function of these? Mostly the codes run in the console. So console is the platform where R is the background. So if you see the console, you can easily find out that the version of R you are using in ours, it is showing that it is 4.2.0. So that is my R version I'm using now. Now the advanced 4.4.3 came, I guess. So you can use the latest version or whatever the version it is. That is the one which is very background R is working. And the one which is on the top is called source. Source is where you can write your code. So you write the code in source and you execute the code in console. Okay. So whenever you run it in console, the outputs are also visible in console. Sometimes a picture or any other files you want to see, that will be visible on the right side panel. That is called the output panel or files panel or package panel or help panel. There are multiple names to it. On the top right environmental panel, where you can see all your history, what you have already, the previous codes you have worked on, and the environment. Environment means if you are running or you are developing a code, you will save some data sets. So whatever the data sets you are saving, those data sets are listed there. So you come to know that what are all the variables already there and how to use them. Next one. Now, so now I begin with R. So if is my RStudio visible? Is my RStudio visible? Okay, I believe it is visible. So if you open I have changed my console into some dark theme because frequently I use it. So I convert it into black. And to manipulate this, how to manipulate this interface, you can, if you open RStudio, go to tools. In go to tools, you'll find an option called Google Options. Okay, you click Google Options, then the entire interface of R manipulation you can do. For example, I have changed my appearance to black through this appearance column. So if you click appearance, then it will show what is the font you have to use and what is the size of the font, what are the different themes you can use. If you click it, you can get enormous amount of themes, or you can create your own theme also, that is available. And if you click OK, automatically it will change. And if you see, my panel is different from the new panel because I have interchanged my panel. Actually, console will come in the bottom to source code, but I have changed it to right top because whenever I run code on my left side, the output will come on my right side. So which will be very convenient for me. So I have changed it. It's your choice that you have to change or interchange. That's up to you. So these are the 2 basic things you should know before manipulating R, because first impression is the best always. If you open R and if you didn't understand anything, that it will be very horrible to start with it. Now, I will start with some few basic codes, how we use it in R. Okay, I'll cancel this. Now I have shared the R codes already with you, I think. So if you directly open it, it will open it here. First one. First, we learn some shortcuts before running into R. The shortcuts are, first one is completing a function. For example, if you want to start a new R file, just click on the tab which you find it here. The plus sign is visible. If you click it down, then there are multiple file types available. So we are going to use RStudio. In RStudio, you can use R, you can use C, C++, Python, SQL, any number of multiple language codes you can write. But here we are preferring R. So if you click R, then you will get a new file called untitled2. So similarly, everybody will get untitled1 probably. After clicking that, so it starts, the blinking one is the cursor where you type your actual code. And if you run it, it will receive, the code will be, the output will be visible on the console. Okay. The first shortcut is tab. For example, in R, we call the codes as functions. We call them as functions. Okay. So what is a function in R? For example, for a data set, I want to calculate a mean. So we know the formula for mean. In R, it is MEAN. So type it, it will show. In this, if you see, there are three terms is visible. One is mean opened with the base in flower bracket. On the right side of it, that there is a box, black color box is opening, that describes what the function is. Okay. So in that, if you are typing a particular function, ME, and if you click tab, automatically what are all the functions in that particular name will be visible. Okay. Then if you click enter, directly that function will come. Again, if you click tab, what all the sub functions are there inside a function also get listed. So tab is a very important function in R for shortcut or quick writing. You can see that here. So if you press tab, automatically it completes or pop-ups the function which you are using. Again, if you tap it again, then it will show what all the sub functions. We call them arguments. We will see that in coming slides. And few other shortcuts. Few other shortcuts are, if you click Control 1, it will go to the source. If you click Control 2, it will go to the console. If you click Control-L, if whatever you had it in, for example, if you had a lot of functions in R, for example, mean of a data set, you're running it. Now you want to clear my console. So you click Control-L, the entire console will be cleared. Okay, so that is one shortcut. The other one is Control-Enter. Whenever you are writing code in source, to run that source code, you have to click Control-Enter. So if you click Control-Enter, automatically that code what you have written in source will be visible in the console. Now we begin with the projects. For example, projects means whatever the particular research data analysis you are doing. In R, we consider them as project. That is one thing. Secondary, whenever you run R, it will take data sets from a particular place. That is called directory, or we call them as working directory. Okay, it is called a working directory where you look for all your saved files, or your outputs also will save there. So how to find your own working directory? First, there is a function called get WD. Okay, you just type GE and tab it. GE and you click tab, automatically it will list everything. If it is not visible, then give the next letter. Get working directory. GET means get, W is working, D represents directory. So how to get a working directory? Just type it and click Control Enter. So if you click Control Enter on the console, you can find out the place where your R is using as its working directory. Whether it is the place. I have D drive. In that D drive, I have two folders. One is results. Inside results, that's a folder called R. from that particular folder, R is taking all its data sets and inputs. That is what it means. Okay. If you want to change that directory to your personal place, if you install R for the first time, generally your working directory will be C users and your name, document, and R project. This will be your working directory. So if you want to change that working directory, you can use that set WD. Set WD is a function where you can set your working directory. Set working directory, open bracket. Every R function will be represented in blue color, and all the inputs you give to that particular function will be in the open and close bracket. Okay. Now set the directory. So set the directory means I want to change my directory to a particular location. So how to identify my location? For example, in my I think you can see my screen. I have a folder called SRM seminar. Okay. So in this folder, I want to save all my codes and outputs. So which means you click on that line, that blue color line, the entire file location is represented in blue color highlighted. You just copy it and come back to R and you paste inside a double quote. Okay. So put the double quote and paste your file location. Okay. And one more thing you have to do is which is instead of left slash, you have to click right slash. Change all the left slashes to right slashes. Okay. Like what I'm doing. So if you do that, and if you click Control Enter, definitely you will get your actual directory will be changed to. So now if you click Get Directory, your working directory becomes that which I have given latest. Statistics Google Drive, that one. Okay. So I'm rechanging it again back because all my data are there in my old directory. So this is just for your reference. You can try to change your own working directory because don't keep your working directory in C drive because OS is there, and if you're running too much of codes and too much of images, if you're generating, all will dump in C drive, which will slow down your system. So better keep a folder outside your C drive and make it as your working directory. Okay. So I have changed my working directory back to my old folder, and if you click Get Directory, I can get back my working directory. Second, so what R version and what type of R version I'm using. So how to check that? Go to global options. In global options, if you see R version which I am using, so it is saying my system is 64-bit system and my R program installed is 4.4.2. So if you want to change that, because multiple softwares or multiple systems, they have used different type of R versions. Okay. So in my system, I have installed 2 or 3 versions of R. So you can change them. I have 3.2.2 version of R is there with me, and 4.4.2 version is also there with me. So I am using the latest one. So I am clicking it and I'm running it. Okay. So this. Okay. Okay. Next we can move on. Okay. Next is how to create a R script. Okay, so to generate a new R script, I have told you already. You can go to File and you can click New and you can click R script. This is one way. The other way is just directly click this plus symbol. It will ask what type of R file you need, that is visible. So if you want R script, just click R script, then you will generate a new new R script inside. The name of my R script which I'm going to use now is untitled one. Okay, so that is star in that name represents it is not saved yet. Okay, if you saved it, you won't find star. So nearby you can see 3 of my tabs where star is not there, which means I have saved them already. Okay. Okay. Next, we will enter into using R. First, how to use R as a calculator. Okay. So you just click the SRM workshop course. I have given the entire code to you. How a R code works. That is what we see. So whenever you type this hashtag in front of a code, which means that code will execute, but it won't run. The meaning is whatever the text you have given after hashtag, it will directly show up in console without booting. Okay, so hashtag arithmetic, which I have given, I just run it. You see, after running it, there is no output got generated. Okay. So one hashtag or 2 hashtag, that doesn't matter. So you can keep any number of hashtags. Okay, but if you click at least one, then that entire code becomes gray, which says that that code is non-executable. Okay. Next is how to display a particular text in R. So for example, hello R is my text. I want to print that text in my console. Okay. On the right side is my console. So if I click Control Enter, so you can see my print hello R is printed on my console. Okay. The second one is same as basic mathematical calculations, 2 plus 3 or 4 plus 5. So anything you can just type it and it will give your answer. SQRT is a function which calculates the square root of any number. Okay. So square root 16 will give the square root of the number 16. 2 plus 5 minus 2 is subtraction. Multiplication, we use star symbol. For division, we use right slash. And for power, we use the up arrow. Okay. Then exponential or power, we can use up arrow or double star. Double star also is used as a power symbol. The next one is called modulo, or we call them remainder or quotient functions. So double percentage symbol represents the remainder, which means if you divide 10 by 3, you will get a remainder of 1, right? So 3 into 3, 9 plus 1 is 10. So 1 is your remainder. So if you run it, then it will show only the remainder. To get the quotient, it is slash will be there between the 2 percentage symbols. If you run it, it will give the dividend. Dividend, or we say the quotient. Okay, you can try for any other number. For example, I want to divide 10 with 4. So obviously a remainder will be there. So put double dollar and 4. You run it, then 10 divided by 4 is the whole number is 2 and the remainder will be 2. Okay, so this will give the remainder. If you divide it with 5, there will not be any remainders because 10 is divisible by 5. So just 10 double percentage 5 will give you the remainder, which is obviously 0. Okay. Okay. Now, the most important topic in R is understanding how a function works in R. Okay. So what is a function and what are all its parts is what we are going to see now. Okay. So in this given slide, you can see that a function in R that is called mean. So mean is a function and it takes few inputs and it will run. Okay. So the inputs are called arguments. We say that x na.rm. Na.rm is rm represents remove. Na represents not available. So is there any empty data sets in that particular data? Remove them. That is the meaning. Okay. So x na.rm, they are called arguments. So any function will take arguments. So each argument have an input. So that input can be a data set, or that input can be a number or a name. So there are multiple things. Okay. So every function opens with open bracket, ends with close bracket. X, na.rm, they are called arguments or parameters what the function uses. Each argument along with its input should be separated by a comma. Okay. So any number of arguments you can give depends upon the function. Okay. 1:2 is a input we are giving to this particular argument. False is an input which I am giving to na.rm, that particular argument. Okay. So remember, functions run by using arguments. So arguments takes the input and the function will run. That is the process. There are different types of functions, which means we can say there are few functions which already built in R. For example, the mean and median, number of observation, length of a data. I will show them. I will show all the basic functions in R. Those functions are already installed or predefined in R. Okay. So no need to install those basic functions. The another functions are called user-defined functions. User-defined means if I want to create a new function, I can do that. For example, I want to add two numbers. An example was given below. Two numbers. For example, A is a number and B is another number. I want to add these two numbers and I want to make them as a function. Okay. So you can use this format. This is a function making format where I have developed a name called add numbers. That is the name of my function. And two arguments. A is an argument, B is an argument. Two inputs I am creating. So what it will return, the output will be adding A with B. Okay. So I'll run this code in R and we'll see what will happen. Okay. So if you come here, built-in functions. Built-in functions are which is already there in the R software. Okay. What if generally if you see whenever you run a function, you don't know what are all its arguments. Every time remembering all the arguments of all the functions is very difficult. So to know about any function, just put a question mark and type that function. For example, I want to know about square root. Just put a question mark and type the function and click Control Enter. So if you do that, on the right side, a help tab will open. That help tab will explain about that entire function. Okay. So my square root is present in the base package. The flower brackets and the word which is inside, you can see that base represents a package which is already built in RStudio or in R, we can say. Okay. So that what it does, it computes the absolute value of X. Okay. Or the square root, it computes the square root of X. Okay. So it is saying what is the usage of this particular function and how to use the function. Okay. What is the input it takes? Arguments. The input, the only input in this square root function is X. Okay. And what are all the other methodologies? And they have given some examples also in the bottom. Okay. So you can easily sorry. Okay. So square root is the function. To know about that function, just put a question mark before it and run it. You can in the help box, you can read the entire description. Next, ABS. ABS is a function which gives absolute value of a number. So absolute value of -10. So what's absolute value of -10? We know which is 10. So ABS is a function. Similarly, you can round a number. So I have a 3-digit number, 3.567, which have 3 decimals. I want to convert that into 2 decimals. So use round. Round is a function. How many decimals you need? I need 2. Click enter. It will convert it into 2 decimals. if you see, if you type round, ROU, okay, R itself showing what all the functions starts with that particular name. So I want the first one, so I'm clicking tab. After that, again, I'm clicking tab. So that says what are all its arguments. So X is an argument. How many number of digits you want is another argument. The dot 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 represents, you can use additional arguments, but they are not mandatory. That is what it means. Okay. I'm clicking X. So what is my input? I am taking numbers. I take my number as 4.723, for example. Then my another argument. My next argument is decimals, right? So how many number of decimals I want? For example, I want one decimal. If I click and run it, we can get 4.7. So that 4.723 is reduced to one decimal, which is 4.1. Your output is visible in the console. Okay. Now, what is this particular thing? T represents concatenate. Concatenate means merging. That is the meaning. Okay. So I have 5 numbers. The numbers are 1, 2, 3, 4, 5. This is one way you can write them. Or if it is a continuous number, you can put colon 5. So 1 is to colon 5 also give the same output. Okay. So which means I have 5 numbers. So these 5 numbers, for those 5 numbers, I want to calculate the mean value. So that is the meaning of this particular code. So these are my 5 numbers. For those 5 numbers, I am going to calculate the mean. So if you click it, obviously the mean for these 5 natural numbers is always 3. So sum is another function which adds up all the data set. Okay, all the numbers. So just run sum, then it will give the total of those 5 numbers. So these are all the functions which are already built in. Okay. User defined functions are the functions which the user creates on his own. I'm creating a new function called add underscore numbers. The function of that particular function is adding 2 numbers. Okay. So how I have created the function? By using the function called function and 2 arguments. A and B are the 2 inputs which I need to give. So 2 inputs means those 2 numbers. And with those 2 inputs, what it will return? It will return A plus B, which means adding them and returning them. Okay. So I have run this. So after running, now I have created a function called add underscore numbers. You just type add. Then if you can see your function, your created function. Add. So you can see here, your created add underscore numbers function stored in the global environment. Global environment is a built-in R package where your created function is stored. If you click tab, your function will come. So what are the 2 inputs you have given? One is A. A is 2, that is your first input. Then B. B is your second input. We take 7. Okay. So if you add 2 plus 7, obviously you'll get 9. So likewise, you can create any number of any complicated formulas into a function in R. Okay. Next is functions present in packages. Okay, what is a package? Package means it holds something within, right? That is the actual meaning. In R, the meaning is if I'm a researcher in genetics, for example. For all my calculations, I try to create a package. What's a package? For every calculation, I will create a function. All those functions are clubbed together and stored as a package. For example, if you go to R, in RStudio, you can find packages tab. You can find the packages tab. You see, these are all called libraries, or we can say packages. A-bind, agricole, ALG design, these are all packages. If you click a package, you will find functions. So agricole, AMMI, bar.err. These are all functions. Each function have its own usage. Okay, so if you click that, you'll get it. So Agricole is a package which contains many number of functions. So you want to use that bar.err function means we have to install this Agricole in R. Okay. So to get any function, for example, we'll go with correlation plot. What is correlation plot? It is a package. It is used to visualize a correlation matrix. So which means after calculating the correlation between multiple variables, you'll create a matrix. Using that matrix, you can create a visual graph of that correlation. Okay. For doing that, you have to install this particular package called CorMat. Okay. In that core plot, you can find enormous functions. This COOL1 is a function. Color legend is a function. Color.mtest is a function. What this function do? Its description is given on the right side. It is a test which is used to produce the p-value and the confidence interval. Okay. So likewise, for any package or any particular analysis you do, its corresponding package you have to install and you have to use it. Now we will see how to install a package. Okay. So this we have seen. The numerical integers we'll see now. Before that, we will see how to install a package. Okay. So in our built-in function called install. Okay. So type that install. You'll find a function called install.packages, which is present in the package called utils, which is utensils or essentials, we can say. So install a package. So which particular package I want to install? For example, I want to install a package called dplyr. DPLYR. So DPLYR is a package name which is already exist. Okay, I want to install that particular package. Just type it under double quote because any words or terms you are using in R, you should put them in underscore so that R can understand that that's a word. Okay. Click Control Enter. So if you click Control Enter, it is showing error installation in mine because I already have that. But if you are a person who is installing DPLYR for the first time, automatically it start running. Okay, and you will get your outputs on the console. Okay. For example, I'll try to install some other package. For example, go to tools. There is another way. Go to tools, click install package, and type your necessary package. If I want to install dplyr means dply. See, it will show the package name to install. For example, I want to install dplr. So this is the package I want to install. Just click that and click install. It will start installing. You can see on the right side. On the right side, it is showing install.packages. It started installing. Okay. So it not only installs that particular package, it also installs its dependency packages. Dependency packages means some packages run with the help of other packages also. Okay. So this DPLR package also runs with the help of the above packages. Signal, XML, R.utils, R methods S3, R.o. These are all the other packages which is used by this dplyr. So whenever you install any package, it will install along with its dependent packages. Okay. And it will show where your package is stored. Okay. So my package stored in this particular location. This is the location where my package got stored. Okay. So once you install a package, you have to bring that package to RStudio to run it. Okay, to import a particular package into RStudio, you can use this library function. Okay, LIBRA. If you type library, obviously it will come. Then You give the package name dplyr, and if you click run, it will run on the console. Okay, in the console you can see library runs, and it is showing the right arrow. Right arrow represents the code got run and the output is successful. Okay. So this is how you can install. This is one way of importing through library, or the other way is you can go to packages, and if you click this check mark, obviously that library will be imported. Okay, it will be visible. You can see. If you click this checkbox, that particular library will load. Okay, that is the another shortcut you can do. If you take that out, it will detach. It will detach from the current R project. Okay. Okay. So we know what is a function now. We know how to install a function now. And we know what is a package and how to install a package. Next thing is what all the inputs are function takes. Okay. Data are divided into multiple types. One is numeric, character, logical, and factorial. Okay. In specifically in R. In numerics, there are multiple types. We can say them as a number or a integer. Okay, integer means whole numbers or numerics. Sometimes you say a largest number, a very large number. L represents lakhs, which is a suffix. Okay. What this function do is, I am storing the value 10 in the name number 1. Okay. I'll just run this code first. The code got run in the console. Okay. If you type num1, you have stored this 10 to this particular name. So if you run this, you'll get the value. Yeah. So this num1 is called object. So objects are a thing which stores the information. Okay. So those are called objects in R. So num1 is an object which is stored with a number 10. That is how you should read it. Okay. So num2 is another object where I have stored the value 3.14. So if you run it, and if you type num2, see here your value which you have stored before is visible on the console. Okay. Next, you are storing an integer. Likewise, you can store any kind of number. Numbers are generally classified into 3 here: decimal, large numbers, and integers. And if you want to know, I have stored a number. Is that actually a number or an integer? How to identify that? For example, 3.14. 14 is in R, it is called numeric, or you can say double. Double means which contains decimal point. That is called a double or a decimal. Okay. I want to know whether this number 2 is of what kind. So to find its type or class it belongs to, use the function called class and write num1, click Control Enter, it will show numeric. So which means in num1, there is a number which is stored is a numerical value. That's the meaning. Okay. You take the second one, integer 1, 5L. 5L is a integer. It is stored in the name int1, which is an object. In class, I want to find out what type of data that int1 is. So I have just given int1 inside that function and I am running it. So if I run, it is saying that in the int1 object, I have stored a integer. That is a meaning. This is one method. There is some other direct methods. Okay. So how to convert a integer? 3.5 is a decimal value. I want to convert that decimal value into a integer. So to do that, use the function called as.integer. So these are all the one thing you should understand from RStudio or R is codes or functions is available. They are in the internet or wherever you go, they are available. But you should know how to use a code and what all the arguments it is necessary to run a function. Okay, that is the basic understanding for any programming. Okay. So what I'm doing, I'm converting this particular decimal number into an integer. Okay. So if you run that particular code, you can see in the console that my number 3.5 is converted into an integer. Okay. Next is 5L is a decimal or numeric, which I'm going to convert that into a numerical value. So click that. See, 5L is a decimal value which is converted into a number 5. Okay. So likewise, there are a lot of functions available. Based on your need, you can find out the function and you can run. We have seen number as one particular data type. Next, what we are going to see is a character. Okay. Character means names or words that we are going to store it in a particular object. Okay. So hello, comma, or apostrophe or exclamatory. So that I have given inside the double quote. This represents that the double quote represents that this is a word or a character. I am storing this information inside an object called car1. Okay, and I am running it. So I am storing hello, comma, r character in character 1. So I have run it, the code is successful. If I want to see what is inside character 1, just type the object name and click Control Enter. It will show what you have stored inside character 1. You want to know what class it is. Is it is a number or it is an integer? You know now, but whenever you go have seen large amount of data set, finding them is a difficult process. If you run it, it is showing that CAR1 is a character. So which means that is its type. Next is merging two different words. Okay, so welcome is one word, to R is another word. So I want to merge these two words into welcome to R. Okay, so how I am doing? I am just giving welcome in double quote, comma, then to R in another double quote, and if you run it, then welcome and to R is merging, and you are getting welcome to R. Okay, you can do that for some other case also. For example, paste, for example, Dinesh, and a number you want to store. For example, I want to store 10. And if you click enter, you see that 10 is merged along with Dinesh with the space. Okay. So this way, using the spaced function, you can merge any number of words. For example, Dinesh is one word, the other word is Kumar, for example. So just run it, they will merge and they will be. Okay. So it's very simple to run. And in this particular Dinesh Kumar word, how many number of characters are there? Okay, how many number of characters are there? We have to find out that. So N represents number of, CHAR represents characters. To get the number of characters inside a given character, for example, Dinesh underscore Kumar. If I run it, so what it is showing? It is saying 12. 12 means there are 12 number of letters present in this one word. Okay. I want to convert this Dinesh Kumar into uppercase. Okay. To convert that into uppercase, you can run the function called to upper. To upper represents converting a small lowercase to an uppercase. Okay. I have given double times the double quote, so that is it is showing error. Okay. So all my letters are converted into capital letter. Okay. Similarly, two lower is a function which is used to convert the uppercase into lowercase. For example, two lower open bracket, put the name which is in capital letter and run it. So it will show your uppercase into a lowercase. Okay. These are all very simple manipulations you can do on your own. You can I have shared this entire Excel file to everybody. So you just open it in RStudio and you just randomly work on it, so that as long as you practice, you will be familiar with it. Okay. Next is called logics. Logics are we call Boolean. Boolean means two outputs, either 0 or 1, or it is true or false, or yes or no, whatever. Okay. In R, we call them logic functions or Boolean functions. Okay. So true always represents 1. False always represents 0. So how to know that? You just type TRUE and run it. Okay. See, it is running. True is a word, right? But still it is running without a double quote, because in R, whenever you type true, obviously the R take it as a logical function. Okay. So what they are doing here, I'm saving true, which is an output, logical output, in the name log1. So log1 is a object. Okay, I'm running it. So what I have done, I have stored true in log1. I have stored false in log2. So what is my log1 class? Obviously, it is a logical function, because true or false is a logical data sets. Okay. Now we are asking R that is my value 5 is greater than 3. If it is true, it will give the answer true. If it is false, for example, I am giving the alternate. Is 5 is less than 3? Is the question what I'm asking to R. If you click Control Enter, it is saying false. So which means R will understand the relationship between numbers by using logical operators. Okay, so true or false are all logical operators. This double equal to represents that they are equal to. 10 is equal to 5. That is the meaning. Is 10 is equal to 5? No, it is not. So it is showing false. In case if I am giving 10 here, you run it, it will say true, because these two numbers are equal. So this double equal to represents equal to. Okay. The next and is an AND operator, which is nothing but multiplication. Okay. So multiplication means if you are multiplying like minus into minus, plus into plus minus. Likewise, true represents plus, false represents minus. Okay. So plus into minus is always minus, which is false, right? So true, which is plus into minus is minus. Okay. R function means it is like we have studied in physics, I guess, Boolean operators, where if you use the R operator, 1 plus 0 is 1, 0 plus 1 is also 1, 1 plus 1 is also 1 plus 1 becomes 0, 0 plus 0 is 0. Okay. So the same way here it is 1. R function is adding. So adding, false is 0. So 1 plus 0 is true, obviously. Right? So you get that. This exclamation mark represents not function. So not true. Obviously, not true means it is false. So these are all some basic Boolean logics we use while manipulating our data set. Whenever we have a huge data sets, and in that huge data sets, I want to get only the particular row of data whose mark is above 60 or 70 or something. So those times we use these logics, which is very helpful in manipulating your data set. Okay. Next is called factor. Factors. Factors means it stores categorical data. Categorical data means, for example, gender. Gender is classified into two, male and female, which is categories, right? So what I am doing, I am storing these information. For example, I copy this and run it separately. Male, female, male, female. These are four informations. Okay. I am storing it in a name called A. Okay. So if you run A, you can get the result. Male, female, male, female. So these are the four informations I have saved in A. I want to convert this A into a factor. Okay. So how you can click FACTOR. So that is a function which converts any data set into a factor form. Okay. So which one I have to change? A I have to change to factor form. To run it, you see the difference? You can easily see the difference. Okay. A just stores male, female, male, female. But once you convert that into a factor, it is saying how many levels of factor are there. So how many levels are there? Male and female are the two levels. This is very useful in designs of experiments. Okay. You have factor one while conducting CRD or RBD. The first, you will give treatments. The treatments are, for example, T1, T2 to T7. You replicate them 3 times. So once you replicate them 3 times, if you convert that particular treatment column into a factor, then it will say what are all the levels you have used. Okay. So this is very useful in designs of experiments. So once you convert here, the same thing they have done, male, female, they converted into a factor and stored it in gender. Okay. Similarly, color, some colors, they have stored it in colors. Now, class gender. So we know gender is a factor because we converted this entire set into gender into a factor. So if you run it, to run the class, it is showing it is a factor. So how many levels are there in gender? We have 2 levels, which is male and female. Okay. Use the level function to find out. Is gender as character means you are converting this factor into characters. Characters are these form. Okay. If you run this, you see the factor now again converted back to the character form. Okay. As numeric. As numeric means, so obviously what it will do, it will convert, it will give a number to both the levels. For male, it will give 2 and female, it will give 1. And it is saying that male, that entire gender in numerical form. Okay. Okay. So now we have seen 4 different data types. Okay. So next is the most important thing, data set. Data set means in data types, we just taken 1 or 2 data or maximum of 4 data and we have stored them. But what in case of large amount of data, we know what is a vector. So vector is a row matrix. Row matrix means, for example, you say 1, 2, 3, 4, 5 are the 5 numbers. Okay. Inside C represents merging them, right? Or concordinate. So the C represents 1, 2, 3, 4, and 5, 5 numbers. You're storing that 5 numbers in the object vector underscore number, which means in the vector, I'm storing these numbers. And if you run this particular vector numbers C, you can see in the console that 1, 2, 3, and 4, and 5. So what is the class of these? You can check vector number. So it is a numerical value, which means only numbers are there inside. So all the numbers together, I am storing it in a name called vector underscore number, which is called the vector. So this object is a vector object, or we can say a numerical vector. Numerical vector, more than one number and all are numbers, which is stored in vector underscore number. Okay. Similarly, more than one letters, I'm storing it in vector character. Okay. So I have stored it. If you check what you have stored, just click Control Enter. You will see that A, B, and C you have stored. Okay. What is its class of vector character? So it is saying that this is a vector of characters. Okay. Similarly for logics, you can just practice them. Okay. Some basic vector operations. Vector operations means vec underscore num. This is a object which is a number of numbers stored in the form of vector. What is its length? Length means how many number of elements are there inside. Click Control Enter. So it is saying 5, which means in the vector num I have stored 5 numbers. Length is the function which we use to get the number of elements. Sum is the function which we use to get the total. Mean to get the average. MIN is minimum, which is used to get the minimum value. Maximum is a maximum value. Okay. And if you want to multiply all the numbers with 2, then vector underscore num into 2 means so every element is multiplied with 2. Adding vector num plus vector num means correspondingly you are adding the numbers, which means 1 plus 1, 2 plus 2, 3 plus 3 likewise. Okay. Vector 2, this square brackets are very much famous and very important in R. That square brackets represents the position. Okay, always the position. If you use the square bracket and you are giving 2 means get the second element. That is the meaning. Okay, in vector num, get the second element. Okay, if you run it, you will get 2. So 2 is the second element. What is our third element? Our third element is 3, right? Yes. For example, randomly I'm saving a number. For example, in the name of A, I'm storing numbers from 10 to 15. So 10 is to 15 represents from the number 10 to from the number 15. If you simply run it, you can get it. You can use equal to symbol or this back arrow with hyphen symbol to saving. Okay, both works. Okay. So I stored 6 numbers. So A is from 10 to 15. The length of A is 6 numbers. I want to get the 6th number. So what is my 6th number? Give it in the square bracket. I want the 6th number, and then it will give the answer. Okay. It's very simple to use and very, very important in our. Next form is two-dimensional. Two-dimensional means row and column will be there. So that's why it's called two-dimensional. Two-dimensional numbers. Homogeneous means all belongs to same kind. It is a number means all the elements in a given particular matrix should be a number. Okay, that is the meaning. How to create a matrix? There is a function in R, okay, called matrix. Okay, in that function, what are all the inputs you have to give? You can check it on the right side. See, these are all the inputs. I'll take this for your reference. Okay, you have to give how many inputs? We have to give data, number of rows, number of column, by row, dimension names. These are all the 5 inputs you have to give to create a matrix. So what is my data? For example, my data is from number 1 to 9, which means I have 9 numbers. I have to arrange them in 3 rows and 3 columns. By row means it will arrange the numbers by row. Okay, we'll run it and we'll see. If we run this code, see, I got 9 numbers, 3 rows and 3 columns. The numbers are arranged in the form of rows. I have given false, so that's why it is arrange that in the form of column 1, 2, 3, 4, 5, 6, 7, 8, 9. In case if you give true, it will arrange in the reverse order 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is the difference. That is what they have given here. So they have written this code in code is written in a single line, but I generally keep this way so that you can understand what are the arguments you have to give as an input. Okay. If for example I have 10 numbers, okay, but I want to store it in the form of 3 into 3, what will happen? See, it is showing a warning. What is a warning? The data length is 10, not a submultiple or the multiple of the rows. So which means with 10 numbers, you can't create a 3 into 3 matrix. Okay, that is what it is saying. But you can make a matrix with 5 rows and 2 columns. Yeah. Run it. See, how many rows are there? 5 rows are there. How many columns? 5 columns are there. I want to arrange them in the form of columns. So I'm giving it false. If you run it, see, here it is arranged in rows. Here it is arranged in column. Okay. This is how you can create a matrix. So this matrix, I am storing it in the name called MAT. Okay. That MAT, I am storing my matrix. Run it. So my matrix is stored. If you print it, then it will show what you have stored inside MAT. Okay. Now I had a matrix MAT. I want to know how many number of rows and how many number of columns are there in my matrix. To find that, use the function DIM. Okay, DIM function gives the dimension of the matrix. Okay, which means first number 5 represents the number of rows. The second number represents the number of columns. Okay, or you can get them separately. N number of rows function, n column function. It will give the number of rows and number of columns. As we used square brackets before to identify a specific number, similarly we are using square brackets to get a number from a matrix. Okay, in our given matrix MAT, it is a 5 into 2, 5 rows and 2 column matrix. What is its 2 comma third element? Is there any 2 comma third element in our matrix? I don't think so. It is showing error because second row is this. There is no third column to get it, right? So we can give 2, 2. So 2 comma 2. So see, second row and second column, the number is 7. So it is giving that number 7 here, the console. Okay. See, here in the second one, it is saying comma 1. First element represents the row, second element represents the column. Whenever you have given empty space and just given comma 1, which means you are selecting only the first column. Okay, that is the meaning. If you see here, you can it is clear. Okay, from matrix, you have to get the first column. Okay, to get the second column, comma 2 will give the second column. Okay, similarly for rows, 1 comma represents the first row, 2 comma represents the second row. Okay, likewise you can do. T represents the transpose. T is a function which transposes your given matrix. Okay, your matrix got transposed. Matrix plus 2 means you are adding 2 to all the elements. So all the elements is added with 2. Matrix into matrix is a matrix multiplication. Okay, number to number it will multiply. Okay, 3, for example, this is the actual matrix is 1, 2, 3, 4, and 5, 6, 7, 8, 9, and 10. And you are multiplying this matrix with that same matrix means 1 into 1, 2, 2 into 2, 4. Likewise, it will multiply and it is giving. Okay, this is multiplying a matrix with its transpose. Okay, this is multiplication of transpose of matrix. So whenever if you study the matrix algebra, then you can understand these. Otherwise, this is not as much necessary. Okay. Is the time for a break or can I proceed, sir? Anybody there in the line? Am I audible? So I think
Yes, 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 yes.
I think you have given 11 o'clock for the time. I have taken 15 minutes extra. I didn't see the time.
I
Can we go
think
for,
we go for break, right?
we can go on. When can we join back?
I think 11:25 or 11:30. You need.
I have no go. I can go directly. It's your
Okay, so we will take it for another 15 minutes or.
Then we'll start by 10:30. 11:30.
Okay, 11:30 is
Okay.
okay.
The meantime, anybody wants to practice, you just practice this basic course which I have shared already. Okay. Learning R is all about how much you are practicing. Okay. Okay. I'll stop my class now. You can go for a break and you'll join back by 11:30. Okay. It's very easy to understand. You can use double square bracket or sometimes you can use dollar symbol. Okay. So dollar symbol will list what are all the objects stored in a given data set. Okay. So just put dollar and whatever all the object you want to run, just click it. And if you click enter, then it will give the data which it's stored inside. Okay. Now I want to change this 4 to 5. How can I do that? So this is my value 4. Okay, this is my value 4. Instead of 4, I want to change it to 5. Okay, so I'm equal to 5 means that particular position is replaced with this number 5. Okay, now if you run your entire data set, you can see that particular matrix have a number of 5 instead of 4. Okay, that is easy. That is what they have given in the add icon. Okay. So this is all about manipulating. So you can run around this code. Okay, take this code and practice. Now, what is a data frame? Okay, data frame is the most widely used data format in RStudio. Okay, it is simple. The idea is it is a two-dimensional table. I'll first run this. I will show you and I'll explain it. Okay. Here I have a data frame. My data frame contains 3 columns. The first column is name. The second column is age. And my third column is score. Okay. So name is an object. Age is an object. Score is an object. 3 objects together merged to make a data frame. Okay. So that data frame, I am storing it in DF. Okay, so if you run this particular code, this your entire data will be stored in DF. So whenever you print DF, you will get your data. That is one thing. Next, what is my size of this data frame? My data frame size, to find out my size of the data frame, use the DAM, which we have already used in matrix. So 3 into 3, which means 3 rows and 3 columns, which means 3 into 3, 9 observations. STR is one of the famous functions in RStudio. If you run it, it will give the structure of your data set. So what is name? Name is a character, right? It will say it's a character. It contains different types of name. Age, what is age? Age is a number. What are all the numbers? Score is also a number. What are all the numbers? So this structure function will will easily say what kind of data set yours is. Okay. Summary is a summary will give the summary statistic. Summary statistics means that mean, median, mode, and those things. Okay. What is the summary statistics for names? It is three. Three means only 3 rows are there. Class, they are characters. In the mode, there is no mode for it. If you go to age, the minimum value is 25. The first quartile value, median value, third quartile, maximum value. All these values it will give for character wise it will give. Okay. Now, okay. Now, how to get a particular column? So name is a column. Okay. I want to get only this particular column. So how to get that column? EF is the data frame. Put $sign. It will give you, and it will give you all this columns. You click Control Enter. That will give all its column. Okay. If you want a particular row, I want the third row. So row we can use by using square bracket. Third row. Okay. If I want the first row, similar to matrix, you can use. Okay. Okay. Now create a new row or a new column. So how to do that? See, df new column pass. There are 3 rows are there, so they are giving 3 inputs, right? 3 inputs in a new variable name called a new column in the data frame. Okay, if you run this and if you see your data frame now, what has happened? They have created a new column in the name of annual column, and they stored 3 information, which is pass, fail, and pass. Okay, that is another easy way of adding a new column to any data frame or data set. Okay, so manipulation and editing is fine, very, very simple to do, which I have explained till now. If you want to do any, you just practice from here, from this point to up to this point. This is completely data manipulations. Okay, how to add a data, how to remove a data. I have given different exercises. You just practice it. How to add a C-bind? C-bind means you are adding a new column. That is why it is called column bind. Okay. You have a matrix. For example, what is our matrix? They have not defined it here, but we'll define matrix. It's not a 3 into 3 matrix. Okay. We have a matrix. To that matrix, I want to change my 1, 2, which is our 1, 2, first row, second column, which is 6, to a number 99. So square bracket, you can give equal to or left arrow, both will work. You run it, and if you run back your matrix, your number 6 is converted to 99. That is one thing, that is modification. Adding a new column. So our matrix is a 2 into 5. So 5 into 2 matrix. So to add any column, you need 5 observations, right? So here only we have 3. So I'm adding 13 and 14. And if you run this, see a new column has been added with 5 numbers. If you are adding a new row to it, I was having 3 rows. You run it, is showing error. Why? Because I have added a new column, but I have not stored it in MAT, right? So since I didn't store it, it is not showing the modified one, but it is showing the previous one. So our matrix is this. So for this matrix, we don't have 3 rows. So what we have to do? We have to store that information in MAT. Okay, I just run this code. That is why it is showing error. If I run this complete line, my entire MAT matrix is transformed with a new column. Now there are 3 rows it is. So I'm adding a new row with 3 elements. Until and unless you save it, you can't add or remove you can add or remove a row in a matrix. Okay. As you see, I have added 3 numbers. See, yeah, I got these three numbers. They're very easy to manipulate. You can just try out of it, and I think you won't find any lag in this course. You can easily run it. Okay. Now we comes into the most important part in this all. I have these codes are already available in my codes. Okay. These modifications, everything I have given in the code also. This PowerPoint I can share. You people can use it. Okay. How to install a package. Okay. So I have showed you this install a package is one function, and you can directly go to install packages in the R program where you can install it. Second, you can load a package by using that library. That is also we have seen. Okay, check whether a package is installed or not by using this function. Okay, how to update a package. These are all very basic things. Okay, now how can you import a data set from any other platform to R? Okay, I have shared 3 files already with you. I will go one by one. What is a CSV file? CSV file is called the comma separated vector, you can say. Comma separated files. Comma separated means each values are separated with commas. I'll give a reference. You can see and you can understand. These 3 datasets I have shared you. If you open this CSV file as a notepad, in notepad, okay, you see all my informations are separated with commas, right? That is why it is called a comma separated vector. Okay, this is one form of data. Okay, you can open this in Excel also, but in Excel it will show as a matrix. Then actual text files. Text files are the files where they are separated by some constant symbol. It can be a comma, it can be a tab, it can be a space, it can be anything. Okay, and our normal Excel file. Our normal Excel file. This we have seen. Okay, so with these 3 and from clipboard, how we can import our data set. Okay, now importing a CSV file. Okay, first, wherever it is, your file is, you should say where your actual file is located so that R can import. Okay, to import a CSV file or to read a CSV file, the function we use in R is read.csv. Okay, this is our Excel file. Okay, you see the function r.csv, what they have given in that, how it works. For any function, you have to give arguments, right? So under the read.csv, these many inputs you have to give. All are not necessary. Okay, I just copy it here and I will explain one by one so that you can understand it better. So read.csv is a file. What are the inputs you have to give? You have to give the file. Okay, you have to give the file. What is my file is, or where is my file is. Then is my header is true or false. That I'll explain. Separated by quote, decimal, fill. So these are all inputs, different inputs. We'll go one by one. Read.csv. Okay, read.csv is the function. Okay, our first input is file. So where is my file is? My file is in this location. So how can I give this an input? Click it here on this name box. Okay, it will your file location is highlighted in blue color highlighter. Copy it, come back to R, put a double quote, paste it inside. Okay, now we have pasted the file location. We have to give the file name also. So what is our file name? Our file name is data.csv. So put another backslash data.csv. As I have told you before, all the black backslashes should be converted to right slashes. Okay. Right slashes. So we have given the file. Okay. First step is over. Second step. Is my data is having header? What is the header? Header means so this variable names are called headers. Yes, my data set is having header. So header is equal to true. Okay. Yes, my data set have header. My data set is separated by separated. So my data set is separated by commas, right? So my data set is separated. SEP represents separated. So separated by what? Commas, right? Quote is used when there is a tab. So this is not useful for us now. Decimal, no, that is also not useful. So these are all the three basic information which is enough to print our data. Okay. Now I'm running it. See, clearly we have imported a CSV file and we have imported here. This is very simple. Now but I have imported, but I didn't store it in any object. Okay. So I'm going to store it in an object. So give a name. I am giving the name called data. So in the name data, I am storing my entire data set. Okay. So run it. So if you open data, you run it, you can see your entire imported data set is stored in the form of the data. Anybody have any doubt in this particular thing? Anybody have any doubt in this? Reading the CSV file? Okay, I take this as no, and I'm progressing. Why CSV with notepad? See, CSV file is a comma separated data. You can open it in Excel or you can open it in notepad. It doesn't mean until and unless its name is CSV, you can open it anywhere. Its properties never change. So that's not an issue. Why I showed it in notepad is you should understand whether the observations are separated by comma or not. That is why I have showed it in notepad. Okay. Next. Next, how to import it from a text file. Okay. To import it from a text file, same thing. We use the function called read.table. Okay. Just use read.table function. So read.table is another function where you can import a text file into R. Okay. Same, you have to give some basic inputs. These are our basic inputs. The others are simply too much of arguments they have given, but that is necessary until and unless for some special cases. But in general cases, that much is not necessary. Okay. I'll just go with the necessary cases. So you have to give a file name. You have to say whether it is a header or not. You have to say whether it is separated with what, and you have to give whether it is a decimal value or not. Same as read out this. No. Same as your read.csv. Okay. Same thing. I have given the file location. right? My data set have header. Yes, we have header, true. Our data is separated with tab. You see our text file, this one, this one. This is our text file. This is separated by a tab. Okay. Observations are separated by a tab. To represent tab in R, we use \t. So this represents tab. My values are separated with tab. Strings as factor, this is not actually necessary. This much is enough. And run it. Okay, so I have saved it actually. You see, 1, 2, 3. So all this entire data which we have in the text file, we have imported to data. Okay, I have stored it in the name called data. You run it, you will get your numbers. Now, how to import your data from Excel? Okay, to import your data from Excel, you have to install a package. Install a package called XLSX. Okay, either you run this code install.package, or you can go here and you can install package and type XLSX. The package is there. You can click install to install. Okay. Once you install it, you have to load the package. How to load the package? Using the library. Library, double quote, XLSX. Okay. So run it. If you run it, your library will be loaded. Okay. I have already installed it, so I'm not installing again. Now, in this XLSX, how to read this particular code? This XLSX represents the package name. From that package, I'm using read.xlx. Okay. If people are familiar with Python, they know import function. Importing a package from one particular, importing a function from one particular library. Same kind, XLSX represents the package. Read.xlx represents the function in this particular package. Okay, I have installed the package already. So if you run this library, then this is not necessary. Okay, this is not necessary. Once you didn't run or load this library, you can use this XLSX to automatically taking it from that particular package. So this piece of code is not actually necessary in case of using this double code. Okay. So what this function is, how this function is. So you see, from the package SLXX, we have a function called read.xlx. What are the inputs you have to give here? This is given. Okay, this is a function, var function. Okay, so what are the inputs you have to do? We have to give the file name. Okay, so what is our file name? Our file name is, we already know, copy the location, paste it, and give the file name. Okay, so I have already file name is here. So this is my location. From that location, this is my file. Okay. Sheet index. So in Excel, we know multiple sheets are there. Okay. You have to bring your data from which particular sheet, that you have to mention. Okay. For my data set, for this my data set, it is present in the first sheet. Okay. So give 1. Instead of, if you don't know the number of the sheet, you can give the name of the sheet also. So since we have given the sheet index, sheet name not necessary. So I'm just stopping the page. Okay. Row index. Row index means from which row I have to take the data set. See, obviously our data begins with A1. So this is not necessary to give. So it is a default term. Start row, end row. These are all just to mention, because sometimes you have your data in the middle, or sometimes you have the data in the end of the sheet. Okay. So those cases you need that. Whenever your data sets in the beginning A1, then these are all not necessary. So this is also not necessary. Column index not necessary. Now, your data set, you are storing it in which form? As a data frame or a matrix? If you want to save it as a data frame, give as dot data frame is equal to true. Otherwise, this is also not necessary because this is the default that it is true. So mostly it will save it as data frame only. Whether your data set have header, yeah, we have header. So that is true. Fine. All others are simply likewise. These are all not necessary. So you should know what are all the codes which is necessary to give. Okay. And one more thing called check dot names. This is most of the people while importing data sets from Excel, they will make this one mistake so that they will get confused. The problem is in my data, all my headers have no double words. All are in single word, right? In that case, it is fine. In that case, you can directly run the code. You'll get the output. If you run it, see, you get output from here. Okay, I change it to 25 to 26. I changed it now, saved it. If you run it again, see, it becomes 26. Very nice to run. Okay, but in case, instead of ID minus ID number. Okay, here R believes that ID and number are two different words. So the number of columns becomes 6 because ID becomes ID 1, number 2, name, age, score, gender 3, 46. And what will happen? It won't run. If you try it, see what happened. Instead, they have put dot. This is fine, but sometimes what will happen? For example, we have a. In this case, we'll see. It is coming up. Okay, it is using. It is replacing. Okay, fine. In case of 100 plants, 100 days of 100 days of planting. This is a variable name which we generally use in agriculture. Okay. Yeah, this is the name. Once you import this in R, you see what is happening. Save it and run it here. See, everywhere it is using dot. I don't want this dot. I want my name as it is. So what I have to do? I have to use this function called check dot names. I am giving false, which means false represents the opposite. So don't check my names. If you check my names, you put them with dot. So don't do that. So give false to it, and if you run it, say you're getting a error. Okay. In some cases, whenever you are importing data from Excel, if you find any space in your data set, try to remove it. Okay, from the original data set itself. Otherwise, it may create this dot problem. Sometimes it may say there is no enough number of rows in your data. Likewise, it will give some different errors. Always try to find out. Okay. 100 names, for example, if we say 100 names. Okay, I'll repeat again. So I have 5 columns, right? First column name is 100 days of planting. Second name is 100 names. Third one is age, score, and gender. So now this is the data set. I'm going to import it in Excel. Okay. In R, sorry. If you run it, what happened? I have given check names is equal to false. Meaning is whenever you import a data set, R will check the names, and if any name contains any character or symbol, then it will show an error. Okay, so to switch that off, to switch that function off, we are saying to R that don't check my names. If my check my names is true, it will check it. If my check my names is false, it won't check it. For example, if I give it true, which means I am telling R to check my names, right? If you run it now, see, it has identified that there is a space in between these So it have replaced the spaces with dot, and this name is started with a number that is not allowed in R. So it is replacing it with the new letter X. Since you told R to check them, it checked and renamed it. Sometimes it may rename, or some other times it may give error. You say R not to do that, it will give what it is, whatever it is, the same way it will give. Okay, and that there is no X here, there is no dots here. Okay, so this is a very handy thing which we generally use it in R. I prefer, though there are three different methods. All these three methods are not my favorite. My favorite is this clipboard. Okay, what is clipboard? So we have some chats. Sir, put question marks in front of. Why are we putting question marks? Okay, the question marks represents our read.xlx is a function which is in xlsx. And what is its description? What it do? We don't know that. Okay, to know that, if you put question mark in front and if you run it, okay, it will open the help box. Okay, this is the help box where it will describe its entire usage. Okay, that is why we use question mark. Okay, that is one. Then that is one question. Then why not loading XLX library at start? Whenever we read, that time we can load it. Not necessarily in the beginning you have to run, or in the end you have to run. If I want to import a data set to R now, so now I'm loading it. Whether you load then or now, that doesn't matter. Okay. Before running this code, you should load it. Whenever you load, not necessary, not a problem. Okay. Okay. Any other questions? Okay. Clipboard. We know copy pasting, right? Whenever we copy a text from one file and we pasting it to the other file, where this copied one stores, the copied one stores in the clipboard. Okay. So the same idea. The idea is, I'll go to Excel. I selected my data. I have copied it. Okay, then come. Then run it here. Okay. See what it is saying. Line 1 did not have 8 elements. Is our line 1 have 8 elements? 100 is 1, days 2, off 3, planting 4, name, age, score, and gender 8. See, this one space in this first name is creating this error, right? So how can we solve that problem? So we can solve that problem by what I do is I put double quote in Excel, concatenate, or otherwise we will do that later. I will rename them here. Okay, 100 days of planting name. I have replaced them to single words. Now I have copied it. If I run it now, then so this is one of the easiest way to import data sets in R. Okay, reader table, same as here also we have used reader table, same inputs, which is file, header, separate, it's from the same. In this reader table, check names is not an argument. Okay, that never works here. Okay, that works only in XLSX. Here it is not. Okay. So and whatever the data you have copied in the clipboard, read it. That data have a header. That is true. That's all. Run it. Now, if you see your data, whatever we copied is coming here. HTTP names, agent. Okay. So these are all the 4 different ways. There are still many ways out there to import data. Okay. There are many packages to import data. These are all very basic, and this is enough, I guess, for importing any data sets. Okay. If you have any questions in these importing data sets, you can do that. Oh, check names. Actually, check names is not an argument in read.table. Okay, it is an argument in read.xlx. That is why it is not understanding that particular piece of code and it is not using. Any other doubts? Okay, we'll progress. Now, I had a data now. Yeah, I had a data now with me. If I have R contains some inbuilt data sets. Some data sets are already inside the R background itself. Few are, I'm saying some few data sets. One is called Irish data. Okay, this is called Irish data. What is an Irish data? Irish data is, I put a question mark, you know what is it? Irish data is an Anderson's Irish data, which is nothing but it is a measure of length, sepal length, breadth, width of 50 flowering plants of 3 different species. Okay, which is Irish, Cetosa, vesicular, likewise. So this is one data set which is freely available in R itself. So whenever you want a rough data to run, you can use these kind of data. Access different sheets. See here, sheet index is given, right? If your data is in the first sheet, give sheet number 1. If it is in the second, give sheet number 2. Likewise, you can easily access it. Irish is a one inbuilt data which is already. When did you install library XLX? I have installed it way back, so that is why I'm not installing it again. So if you want to install, you can simply use that install library and you can run it. Since I have installed, I didn't show that. Irish is a known data set. I want to know what is the size of this data. So to know the size of the data, we have know the code called what? Dimension. Okay, dimension of my Irish. So dimension of my Irish is a 150 row with 5 column data set. Can I view it? Yes, you can view it by using the function called view. It will view it in a new page. See, the first column is sepal length, sepal width, petal width, and species. So 5 columns are there. And how many rows? 150 rows are there. Yeah, you can view it. Can you see only the top 5 rows? Yes, you can see top 5 rows of Irish. Head represents the top part. Okay. FISAT is what kind of data set? Actually, there are ready-made packages for every data types. Some people use some satellite images. They are all in grid form. So you have packages for those. You can find them by directly go to search it in Google. You can get the package name. Okay, the FISAT kind of files I have never used, so I don't know, but you can import. That is possible because packages would have been created. It will be available. Okay, head iris means it will show the top 5 rows of my data set. Okay, you can see here top 5 rows. Head 10 means first 10 it will show. Not 5, actually, it is 6. First 10. Oh, this is data because our data have only 5. Instead of data, I have to give Irish. So it is showing the first 10 observations. Okay. Tail is the last 6. We'll give the last 6. Then if you specify the number, it will give the last 10. Okay, so very simple. Summary we have already studied. It will give the descriptive analysis. Okay, what is the minimum, maximum, which we have seen before. Column names is the function which gives the columns. Column names. How many column names are there? 5 column names are there. Okay, that is the number of rows, Irish. Okay, number of columns, dimension, all these things will show what is your data structure is. Okay, now how to filter? Filter means how to select a particular subset of information from a large table. Okay. For example, I have taken a small data set, data frame, which contains names in the first column, age in the second column, score in the third column. Okay. Now I want to get the subset of this. So I need a subset from the data set DF. What is the condition I'm giving? Who are all having age more than 28. Okay. If we run it, you can see the output that whoever having the age more than 28, which is 30 and 35. 28, I have given more than 28, not more than or equal to. Okay. If you give more than 28, it will give all the numbers greater than that. If you give more than or equal to 28, then it will include 28 and it will give. Okay. Similarly, if I have some two conditions, we studied this and means and function. It should be greater than 85 also, age should be less than 30 also. So two conditions it should satisfy. Okay. So if you see our original data, how many of the people having score more than 85? So 85, 90, 88 and 92, 3 people, right? Age above 30, this both conditions who are satisfying, you will get that particular subset. See, age score is above 85, age is below 30, less than symbol, so it is below 30. So these two. So these are all the two people having satisfied these two conditions. Okay. Now you can reduce the you can select only some particular columns. Okay. You can select some particular columns and you can give conditions. Okay. How it is working? I need a subset from the data frame who are all scoring more than 85 and don't give all the 3 columns. Give me only the name column and the age column. Okay. DF is the first argument. Score condition is the second argument. Selecting the number of columns is the third argument. So in this function, we are giving 3 arguments as inputs. You keep all your arguments one by one like how I have given, which will be very easier for you to understand. Okay. All these manipulations, things and all, you can do by a very interesting package, which is called the deployer. Okay. So nowadays, most of the people are using deployer R for manipulating their data, whatever the data sizes. Manipulating those data sets using deployer is one of the easiest way. For example, I have iris data, right? In my iris data, if you just run this library, if you don't have this library, install it and run it. In this library, they use a new notation called percentage greater than percentage. This is a notation, which means run this first. With this, run the next step. So which means this is the first step. Then this dollar greater than dollar will allow to do the second step. Likewise, we will do one by one. I'll say group. First, I want to know what are all the variable names in Irish. So the variable names are subpetal and petal and the petal with. Okay, I want to group my data set. Grouping means based on which particular variable categories I am grouping. Okay, for example, I am grouping my entire iris data by using species. Species is one particular variable name. You run it, what it is saying, our data set, my iris data set is grouped by using species. So how many groups are there now? We have 3 groups because we have 3 species. Okay. Now, from these 3 groups, this is one way of grouping. From these 3 groups, I want group wise average. Okay. So to get a group wise average, summarize is the function you have to use. Summarize. What do you need? You need average. So which is mean. Mean. So mean you have to store it in which form? I want to store it as a mean data. Mean. That is the name I'm going to give. Okay. And one more thing you have to do. We have grouped it. But if you take the average, it will take, there are 3 sets are there. One is setosa, the other one is versicolor likewise. Run this code, let's see what is happening. It is showing that the argument mean is implied only for that particular species. Okay, so X argument is completely missing. For example, I'll give a clear example so that you can understand better. Okay, we'll take this. This data set is very small. Okay. So using that data set, explain a little bit of. Yeah, I'll explain. Tooth growth is a data set. Like iris, tooth growth, this one kind of data set which is available in R itself. So what is the information it is holding? We can use by typing question mark before it. Just type the question mark, so it will show its description. Is it that effect of vitamin C on the tooth growth in Geneva pigs? That is the data set which is available. This data set contains 3 informations. One is 3 different doses of vitamins they have, and 2 methods of delivery, and they have measured the ascorbic acid concentration. Okay, you just run this data set. We want to see the head. What is it? What kind of data they have saved? Just use this tooth growth head function. Tooth growth. You see, they have used 3 columns. First one is the length of the tooth. Second is the supplements, and what is the concentration they have given. Okay, this is the data which is stored here. Now, with that data, okay, tooth dot growth. I want to group it. I want to group it by using supplements, for example, by using supplements. So which means based on how many different types of supplements we have, that also we don't know. So how do we know? Using the structure function. Use the structure function. Tooth growth. So the first length is a number. So 60 observations are there. Okay. Second is the supplement. How many supplements? 2 supplements. OJ and VC. 2 supplements are there. What is the concentration of doses? The doses are all in numeric, but the doses are not actually numeric. They are factors because they have used 0.5, they have used 1.0, then they have used 1.5. 3 different doses they have used. But R understands that these doses are numerical values. So we have to convert these doses into factors. Okay, so how do we convert that into factors? How to do mean difference before and after treatment? I'll show that. I'll show it here. Mean difference before and after treatment. Yeah, we'll see. Okay, so I want to convert my dose into a factor. Okay, so how to do? I want to mutate. Mutate is a function. Mutate means change. I want to change my dose function as a factor. As factor is a function in R. Okay, so if I run this, and if I see what is my structure of my data, my dose becomes factor, and how many levels of dose I have? 0.5, 1, and 2. Okay, so how this function is running? First, load the data, then convert my dose variable as a factor and store it in dose itself. Then bring its structure. So this is how one by one the code will run. Okay. So now we have converted into doses. Next, what we have to do? There is one interesting question: how to find the mean difference between? That example will be very easy to understand. Okay. Can you repeat dose factor conversion? Yes. See, this is in the form of number. Okay. For example, I'll show one simple example. I have a variable A. In that I have stored three information: 1, 2, 1, and 2. In general, if I run it, A is just a group of numbers, right? In case, what if 1 represents male, 2 represents female? In that case, 1 and 2 is not a number, but it is a factor containing male and female, right? In that case, you should not take 1 and 2 as a number. You have to use that as a factor. So as dot factor, so you are converting this A, okay, that A as a factor. So what it is saying? So this 1, 2 becomes a factor, and how many levels are there in my factor? Which is 1 and 2. Okay, the same kind. We have a data set. In that data set, the dosages are not actually numbers. They are three different concentrations, right? So 0.5, 1, and 2 are three different concentrations. Though they are not numerical values actually. So I want to convert that dose into 3 levels factor. Okay. So what I have did, I have converted this dose into factor. Okay, and where I have saved it, I have saved in the dose itself. Okay, and change it. Mutate means change. Okay. So if you run it, obviously we have run that code before. Previously, it is in the form of number. After running this particular piece of code, it becomes a factor. Okay. Some people have asked for finding the difference between the treatment means. For example, I am taking some random numbers. X is before dosage. For example, this is before. I have some 10 numbers, 1 to 10. No need of bracket is not necessary. You can directly give 1 is to 10. What is the meaning of this 1 is to 10? Before the values are 1 to 10. Before you understand. So before the values are 1 to 10, after applying some treatments, for the same 10 observation, the values are 1 to 3 to 12. Okay, now you look at them in the form of data frame. Data frame before and after. capital A. Okay. See, this is before. These are all the information I got. After applying some treatment from the same individuals, I have collected the after values. Okay, so before and after. There are multiple ways to do that. One is directly subtract them. Before minus after. This will give you the information. This is one way. The other way is, for example, I have a data frame A. Okay, so in this data frame itself, I need a new column that should contain the difference, right? So which means you need a new column. That column name is difference. What you are taking difference? You have taking the difference between before minus you are taking the difference between after. Okay. Now look at your information here. See, all your differences are there in the new column. Okay. Is it clear? Okay. And for my toothpaste data, first I have converted them into factor. Then I have grouped. Okay, I have grouped them by supplements and dosages. Supplements and dosages. So how supplements? How many supplements are there? 2 supplements are there. How many different doses are there? 3 different doses are there. So the combination is 6, right? So can we change the difference into absolute? Definitely yes. How can we change that? This difference is an absolute value. So type it as, to get an absolute value, type ABS before. Okay, that's it. Run it. See, now A becomes absolute. Okay. Now we just understand this, what it is. Okay. First, I have converted toothpaste is the data set. First, I have converted my dose into a factor. That is my first step. My second step is I'm grouping the entire data, this particular data, entire data by using supplements and dosages. Okay, that we have already run it here, which means there are now 6 different groups are there in my data set. Okay, for each group, I need the number of observation, minimum number of value, maximum number of value, average value, and standard deviation value. So how to get that? Use the function summarize. Okay. So if I run this now, see what it is giving for the supplement OJ with the concentration 0.5. The total number of observations present in the data is 10. The minimum value among them is 8.2. Maximum value is 21.5. Its average is 13.2 and its standard deviation is 4.46. Okay. So likewise, you can add any number of functions, not only these. This is just a glimpse. Okay. If you only need average, remove all the remaining. I need only the mean and standard deviation. Okay. Now we run it. You will get only the mean value and the standard deviation. Okay. That is one easiest way to do. Can we create our required data sets? Yeah, definitely we can create. Any kind of data sets you have, we can create our own data. That's not a problem. Now, though I have created a table, still it is in the form of a group. So I'm ungrouping them. So I have grouped them here. I'm ungrouping them again here. That is why I'm using this. So whether your data set is of any size or any form, okay, any specific information you need, you can easily using this DPLOR. What only for DPLOR we can conduct a workshop. So that much big package it is. Okay. So these are some basics. So with these basics, I think you can, if you go through, you can get the other things better. Okay. Practice all this. Why ungroup? Why ungroup means whenever you are calculating, if you didn't group, okay, I'll say why we grouped it. If you didn't group, what it will happen? It will, for example, I'm not running this particular piece of code. Okay. What will happen? It is giving overall mean value and the overall standard deviation. It is not giving on the basis of the those combinations, right? That is one. That is why we are grouping. Why we are grouping two way? Why don't we group only by dose? If you group only by dose, how many doses are there? We have 3 doses. So only dose wise values we will get. Okay, this is only dose wise average. I want both dose wise also, supplement wise also. That is why I am grouping them dose wise and supplement wise. So if I run it, I am getting the means and standard deviations dose wise also and supplement wise also. Okay. Then if you didn't undo, whenever you do any other further analysis using this piece of data, this grouped thing will be there already exist. So whatever the function you apply after, it will only applies to this group wise. It won't apply entire data set. Okay, so to apply for the entire data set, we have to remove this grouping by using this ungrouping. Okay, is it clear? How to export the results? Okay. I didn't include that in this, but I'll tell you how to do that. There is a function called sync. Okay, sync is the function where you can export data anywhere. For example, I want to export this piece of results. Okay, so whenever you have a data, first you have to store that in a particular object so that you can export. Okay, so I'm storing this here. I'm storing it in A. So now I want to store where in the form of what? That is two things we have to do. For example, I want to store it in this particular folder. So this is the folder where I want to store. So copy the location of the of where your desired location. Put them in the code. Okay. So this is the place where I want to store in the name of what? For example, I want to store it as a text file. The name of the text file is results, which I give. It's txt. Txt is the form of text file. In your all right slash backslashes, you have to convert it to right. Okay. After doing that, you just run it. If you run it, a random file will be created in the name of result.txt. See, result.txt is a file which is created, but that is an empty one. That is empty because we didn't store anything inside. We just created it. To store it, after giving this sync, after creating the document, we just run the command which you want to store. I want to store A inside it. So just run A. Okay, I have stored enough. I want to close it. Give the same function sync and run it. Now, if you see the results, the data which you have run is stored here. Okay, this is one of the easiest method. I have used different methods. I ended up here, which is one of the easiest way to store. Okay, so this way you can export your data. This is one kind. The other kind is the regular copy paste thing. Okay, the regular copy paste thing. How you can copy is there is a package called Clipper. Okay, Clipper means clip means copy. R means in R. So clip R is a package. You have to install that package. In that package, there is a function called read.clip. No, write.clip. Right dot flip. Right dot flip means what you want to copy. I want to copy the data A. Okay, so if you run this code, A is stored in the clipboard. Now, wherever you want to paste, you can paste it. Whether it is in Excel sheet, you can paste. Whether it is in a Word file or a text file, you can paste. Wherever you want, you can paste it. This is another form. Okay, these are all the two basic things I generally use. Okay. Why again sync? Because you opened it, so you have to close it. Once you click sync and if you run it, whatever you run after sync, it will start storing in that particular location. Until you close that, it keep on storing there. Okay, that is why we have to do sync again. Can you calculate the percentile variations from mean? Yes, we can calculate. So if you go very specific like that, now we can complete. Can you repeat that clipper usage? Clipper, okay, I'll explain. Clipper, okay. Clipr is the package. In that clipper package, we have a function called write underscore clip. Is a function. What it will do, it will just copy the information. So A is the information I have. That I have just copied it. This entire statement represents copy. Okay. Then wherever you want to paste, you can paste it. That's it. Okay. Now, so we have not entered into data visualization. Okay. Data visualization is a vast area. I think I'll show you some basics of data visualization, then we'll progress. Okay. Hello. Hello. Where is my PowerPoint? Okay. Data visualization. See, visualizing data in R is not a, I don't know, it is a very complicated thing. If you are very good in Excel for doing all the basic graphs like bar plot or line plot or histograms or scatter plot, or for all these basic plots, use Excel, because Excel is the best way you can create simple graphs. Okay, you can easily edit colors, everything you can do. Why I'm saying that? I'll show you one piece of code which I have created. Okay, this is my piece of code. This one piece of code is only for creating one particular image in R. Okay, which is so complicated if you didn't understand its basics. Okay, so if you are making very simple graphs, go with Excel. Unless in some cases we create box plots, where in nowadays in Excel box plot is available, though you won't get the diversity in Excel like box plot. Then we can discuss tree plots, scatter plots, then multiple line plots, multiple factor plots. So whenever you do multiple graphs, that time R is the best way to do. Okay. So for multiple plots, for example, if it is a box plot, only I'll teach you how to do box plot in R. Okay. For all others, I have given the code here, the graphs, codes, and all available here. You just practice it. I will explain how to do a scatter plot now. Okay. Kindly tell me how to calculate the percentage deviation from mean or deviation from, because it is percentile variation. Deviation from mean means you are saying from a particular number how much it is deviated. Okay. I'll try now. The same data set what she has, what we have already done. That I will repeat. Where is it? Okay, this data set. So before, after A, okay. So this is our data we have. So now we want the average deviation from before. Okay. In that case, A, you need deviation from mean. So I'm giving the name deviation of mean. That's just a name. Okay. So $A before minus mean of before. Just run it and see your A. See, the average of before is 5, not 5 actually, it is 5.5. So 1 minus average 5.5 is minus 4.5. Likewise, you can get it. So this, I think this is one of the easiest method. Is it clear? Okay, now we will go to box plot. How to make multiple box plot. Okay. So to do or to make box plots, I use the package called ggplot. Okay, for most of the graphical representations of data, I use ggplot2. Okay, in that ggplot2, you have to give inputs in this order. The order is first you have to give the data, then you have to give its coordinates. Coordinates means the x-axis and y-axis. That is called a mapping. Then the layers. Layers means histogram or pie plot or scatter plot, whatever it is. Then you have to give the scale. Scale means the x-axis and y-axis scale. Then facet. Facets means for multiple variables. Okay. Then what theme you want? So this is the order. So you want to know the first three basics. First you have to give a data. Then you have to give the aesthetics. Aesthetics or mappings, or we can say axis. And what graph you want, whether it is a histogram or a box plot or something. Okay. Now I have a data set, right? This is our data set, truth growth. I want to create a box plot for doses. Okay. So which means I'll run it and I'll explain. You see, this is the graph. This is in classic form. We can do black and white. Themes. Toothpaste is the data. First step data we have given. What is our x-axis and y-axis? Our x-axis is our doses, right? That is why I have given x-axis as factor dose. Why? Dose was a number. Okay, but if you take dose as a number, you won't get the same. Okay, so I want to convert the doses as categories. So I have created them as a factor, and I say that is my x-axis. My y-axis is the length of the tooth, because this is a tooth growth. So my y-axis is the length of the tooth growth. So this is my data. This is my axis. Then what graph you want? I want a box plot. Okay. So box plot I want. What color I have to fill? I have to fill with a gray. This color represents the border outline. So the outline is black and it is filled with gray. And what themes? There are many themes in R. Okay. To know them, you just type theme. Then it will give tons of themes are there. So each one gives some different colors. Okay. One of my favorite is classic. Okay. So likewise, you can create. I have another data. Okay, this is my data. I'll show you how the data looks like. See, since it is very basic course, I can't go faster. And I was not able to complete it. But I will give a glimpse of making graphs so that you can use this piece of code and you can try it out. Okay. my current data, this is my data which contains variety, treatment, and note. Note is the value, treatment is the type, variety is the number. Okay. For that, I need to create a ggplot. Okay. See, my data is this. Our data structure. Our data structure is we have a variety, we have a treatment, and we have a node. Okay. I have X in the varieties, which means A, B, C, D, E, F, G are my varieties. Y is my node. This is the value. Fills are called treatments. So A have two treatments. B have two treatments. C have two treatments. Likewise, 7 into 2, low and high. 7 into 2, totally 14. And we have created. So for this kind of multiple graphs, you can't do that in Excel. Okay, you can do only it in either in R or in some other packages. Okay. And we can add a theme. Any theme you can add. THEME theme. You can give a dark theme, black and white theme. And if you run it, it will come in black and white. That's wrong. So, you'll get a box like that. So likewise, you can change. I have so take this piece of code. I think I have shared it with you. You have you can contact me anytime through mail. Okay, if you have any queries, you just list out your query. Or if you need anything related to, you just list your queries. And if you have any doubts, you can share. If we teach too much today, then you will be in moons. You won't remember what we have talked. Okay, so I'll end my lecture here. And if you have any queries, you can ask me now. So we have a 5 to 10 minutes of discussion, then we can wind up. RStudio is an environment. RStudio is not a, it's a software. It's a software. R is not a software. R is a language. Like C, C++. R is a language. Okay. RStudio is a software which is used as an environment for R. Okay. So R is the language, RStudio is an interface or environment, actually. Mail ID. Okay. Right. I'll type my mail ID here. My personal mail ID. So anyone want to any queries, you can contact me here. This R is better than Python in certain areas. If you have a let's see, if you take R and Python, R is most simplest and easiest than Python. Okay, I have used both. Python is very useful when you are doing machine learning. Okay, now we are increasing the interface of R also. But if you're doing any machine learning data sets, you have huge amount of data. So R is very much efficient. So not R actually. Python is very much efficient in handling large amount of data. If you have very small amount of data or small quantity of data, you can go with R. R is versatile. Okay. But if you know R or Python, learning the other is very easy. R is object oriented, Python is sorry, R is function oriented, Python is object oriented. Okay, so in R you have to first call the function, but in Python we call the object first. Okay, that is the difference. Other than that, both are same. Can convert
Hello.
R code to Python code.
Hello.
Yes, sir.
This is Perisami as organizer.
Yes, sir.
Okay, I hope the participants get the basic of the RStudio as well as that console operations. I think the morning session was well conducted by as well as the way of that delivering lecture as well as the teaching the commands, other things is going to be a very humble and slow manner to easy way to catch by the learners. Even the first time introducer of the tar can also they can very easily learn. And the thing is, the time is very um, constrained to us. Because of that, we are not able to go much depth in that data visualization, I think. This thing will you can learn as that Dinesh Kumar given as code. The way you are writing the code is the int. You can use the different type of the data visualization, how it is going to be coded. It is nothing but trial and error. It is not going to be make teach and mug up. It is the thing you are going to be practicing. Then only it is going to be fixed in your mind how the data analysis is going to be taking part with the basics. So with these comments, I conclude the morning, the forenoon session. Uh, I express very much thanks to the Dinesh Kumar for sparing the time for this movement and the wonderful way of conducting the session. And the announcement to the participation, we are giving the break to the uh, organizers as well, the resource person and the participant. Again, the session will be going to be started at 2 p.m. Don't make delay to join. Otherwise, you lost some of the interesting thing. That afternoon session also very much interesting. How the same data visualization going to be again conducted by afternoon session also, because the afternoon session is going to be deal how that correlation, regression, and principal compound analysis is going to be carried out. So these things is going to be again teach to you. Don't miss and join in a prompt manner. That is what the request from that organizer side. Thank you, Dinesh, and thank you, the participant, for sparing your wonderful time in the morning session. Thank you.